Hey guys, now we're going to talk about codominance. And codominance means that it's one of it breaks Mendel's law of dominance. Basically what it's saying is neither allele is dominant. So even though right now we're considering things to be either dominant or recessive, that doesn't work in this situation of codominance. So both traits are going to be there equally. And the example that we talked about in class was a roan cow, which is neither red or white, but somehow both colors at the same time. It'll have big portions of white and big portions of that red color, and so that makes it a situation of codominance. And another really cool situation of that is human blood typing. So basically, human blood typing is a 3-allele system where we have O, A, and B. So all 3 alleles can represent something. O is considered recessive, but A and B are considered codominant. Both of them are dominant. So where you have a situation where both of the alleles are A and B, the blood type is AB. But with this A blood type, you could either be AA or AO because O is recessive. So that blood type would still represent as the letter A, even if there's an O as the second allele. And it's the same situation for the B blood type. You could either be BB or BO because, again, that O allele is recessive. So in a situation like this where it asks us to write the genotype homozygous, remember that homo in Latin means the same. So if it's saying it's homozygous for the B allele, that means that both alleles are going to be B. And right here where it says it's heterozygous for the A allele, because hetero means different in Latin, we're going to say that this is AO. And then right over here, we've got a blood type that's the letter O. In order to be O, the person has to have both of their alleles as O. So that's an OO blood system, blood type. And then type A, but has a parent that's type O. If that parent is type O, this is their genotype, and they only have an O to give. So now we know that their second allele is an O, so that's an AO person. And then right here we have type AB, and the only blood you can be if you're AB is AB. All right, if we went over and switched on to the back side here, we've got a couple problems. For instance, right here we've got a father who's a father who's O and a mother who's O, which means that both of them are OO, which makes it kind of boring because all they can have is an O baby. So we got 100% of their offspring are going to be O. Here we have a father that's A, that's homozygous, and a mother that's B, that's homozygous. What that's going to look like is one is going to be AA because they're homozygous, and one's going to be BB because they're homozygous, which means that 100% of the offspring are going to have that AB blood type. So we'll just say 100% there. All right, now this is kind of fun though. This is one of my favorites when we've got heterozygous parents, because if we have an A for heterozygous, that means that they're AO. And then the mom's B but heterozygous, that means they're BO. So we've got AB, BO, AO, and OO. All 4 possible blood types can happen with this pairing. That's pretty amazing. All right, and then here we've got a father that's type O and a mother that's AB, which means we're going to have, it's going to be 50-50 BO and AB. All right, let's skip down to number 16 together, where it says we've got Mrs. Essie, and she's got type A blood, and Mr. Essie has type O blood. Now, we don't know unless we get more information what her second allele is, but they've got 3 kids, Matthew, Mark, and Luke. Mark has O blood, Matthew has A, and Luke is AB. Now, based on this information, we know that Mr. Essie has to be OO. But Mrs. Essie, in order to have an O child, if we kind of write it together in a Punnett square that looks a little bit like this, we don't know her second allele yet, but we do know she has an O child. Is it possible? Absolutely. If this second allele is an O, then it's a 50-50 chance that her kids either got A or O. So we're going to say that she's AO because Mark is O. Here's the crazy thing though. Luke, who has AB blood, if Mr. Essie is O and Mrs. Essie is A, where did he get that B from? So Luke cannot be their child because he's got that B allele. All right, we'll do 2 more for this. Some of my favorites. And that is, so we've got right here a situation where we've got a mom and a baby, but they don't know who the dad is. So we've got a mom, she's got type A blood, and a dad with type B. And we're going to make the assumption that her second allele is an O. Otherwise, she couldn't have a B baby. So she must have given that baby an O. And we don't know if the mailman, the butcher, the waiter, or the cable guy is their dad. But let's look at these alleles here. If we've got an O mailman, he can only give O's, so there's no way he could give that baby a B. So we're going to cross him off. And this waiter right here, he could either be AA or AO. We don't know, but he doesn't have a B to give. Got the butcher and the cable guy, and they do both have a B to give. So let's just see if it's possible. We'll draw 2 Punnett squares. We've got this AO parent, and then here we've got an AB possible parent. We could have an AA, an AO, an AB, and sure enough, we can have a BO. So he's a possibility. And then we've got the cable guy who's B. We don't know if he's BB or BO. Let's just assume he's got 2 B's. Either way, here we go. It should be a B. That's a possibility as well. We've narrowed it down to 2, but we still don't know who the father is. All right, and this will be our last one. This parent right here has OO blood, and then the baby has AB. And this baby, there's no way that it could come from this mother. So this situation here, we wouldn't even need to look at the fathers, because if she only has an O to give, this AB blood would be impossible.